The first alert looked like a typical latency spike. API response time above threshold, then another. Database CPU above 85%. Slack followed immediately. Search is slow. Product pages taking 6 to 8 seconds. Seeing timeout errors in checkout. I opened Grafana. Request rate was normal, nothing unusual, but latency had doubled, then tripled, and database CPU was climbing fast. What didn't make sense was this. Traffic was steady, but the system was behaving like it was under heavy load. We were running on AWS, primary region in US East 1, EKS cluster with around 85 microservices. Traffic averaged about 3K requests per second. We had Redis as our primary cache layer, used for product data, search results, and session caching. Database was RDS PostgreSQL with read replicas. CloudFront sat in front for static assets. Application traffic went through an application load balancer into Kubernetes. Monitoring stack included Prometheus and Grafana. Cache was critical. Without it, most requests would hit the database directly. Users reported slow page loads, search results delayed, checkout timing out. But the system was not down, it was just slow, which is often harder to diagnose. Pods were healthy, no restarts. Application CPU was moderate, but database load was unusually high. That was the first signal. More queries were hitting the database than expected. We checked cache metrics. Hit rate had dropped significantly, from around 85% to under 20%. That explained the database load, but not why the cache was missing. First thought was cache eviction. Maybe Redis was full. We checked memory usage, within limits. Eviction rate was normal, no spikes. Next thought was cache key mismatch. We checked recent deployments, nothing obvious. No major changes in caching logic. Then we checked Redis itself. Keys were there, but access patterns looked different. Fewer hits, more misses. Application checked cache, miss, then queried database, then wrote back, but subsequent requests still missed. That was strange. Cache should warm up quickly under steady traffic, but it wasn't. Now Slack was escalating. We dug deeper. Earlier that day, Redis had been restarted. Routine maintenance. No data persistence was configured. No snapshots. No AOF. We had recently introduced a change. Cache population was now tied to asynchronous workers. Under normal conditions, it worked, but after the restart, it failed. The workers were not keeping up. They processed updates slowly while incoming traffic continued. Every request missed cache, hit the DB, and queued another write. A backlog formed. Cache remained cold. Database took the full load, and the system slowed down. We had to find why the cache was not serving data. First step was to reduce pressure. We temporarily scaled read replicas. Then we enabled synchronous cache writes for critical paths. Immediate population. Next, we increased worker capacity, processed the backlog faster. Cache hit rate started climbing, from 20% to 40%, then 70%. As hit rate improved, database load dropped, latency followed. Within about 45 minutes, system performance stabilized. Response times returned to normal. What failed was not the cache itself. It was how we depended on it. We treated cache as optional, but the system relied on it heavily. Detection was incomplete. We saw database load and latency, but we did not alert on cache hit rate drops. That was the real signal. Cache layers should be treated as critical infrastructure, not optional optimization. Cache hit rate must be a first-class metric, with alerts. In the end, nothing crashed. But the absence of something invisible changed everything. Test your failure scenarios, not just steady state.